this module. You will learn to calculate the percentage composition of the elements present in organic compounds. This is also known as quantitative analysis. First, let us see the method of estimation of carbon and hydrogen in an organic compound. Carbon and hydrogen in the organic compound are estimated by Liebig's method. The apparatus used for this method consists of a combustion tube packed with copper oxide pellets, a platinum or porcelain boat, 2 pre-weighed absorption tubes, and a burner. In this method, a known quantity of the organic compound is placed in the platinum or porcelain boat. The boat is placed in the glass combustion tube packed with copper 2 oxide pellets. One end of the combustion tube is connected to the oxygen supply, and the other side is connected to the 2 U-shaped absorption tubes. One of the absorption tubes contains anhydrous calcium chloride, while the other contains concentrated potassium hydroxide solution. Now, the combustion tube, along with the boat placed in it, is heated and pure oxygen is passed through it. As a result of combustion, carbon dioxide and water are formed. Water in the mixture is absorbed in U-tube containing anhydrous calcium chloride, and carbon dioxide is absorbed in another U-tube containing concentrated solution of potassium hydroxide. The U-tubes are weighed again after this absorption. The increase in the masses of calcium chloride and potassium hydroxide is calculated to get the amount of carbon dioxide and water in it. From the amount of carbon dioxide and water, the percentage of carbon and hydrogen are calculated. Let the mass of the organic compound taken be m grams, and the mass of the water and carbon dioxide produced be m1 and m2 grams, respectively. We know that 44 grams of carbon dioxide contains 12 grams of carbon. Therefore, the carbon content in m2 grams of carbon dioxide may be calculated as 12 multiplied by m2 divided by 44. Now, m grams of organic compound contain 12 multiplied by m2 divided by 44 and m. Therefore, 100 grams of organic compound would contain 12 multiplied by m2 multiplied by 100 divided by the product of 44 and m. This gives the percentage of carbon present in m grams of the given organic compound. The percentage of hydrogen is also calculated in a similar way. We know that 18 grams of water contains 2 grams of hydrogen. Therefore, m1 grams of water contain 2 multiplied by m1 divided by 18. Now, m grams of organic compound contain 2 multiplied by m1 divided by 18 and m grams. Therefore, 100 grams of organic compound would contain 2 multiplied by m1 multiplied by 100 divided by the product of 18 and m. For the estimation of nitrogen, 2 methods, the Dumas method and Kjeldahl's method, are used. In Dumas method, a known mass of an organic compound is heated strongly with coarse cupric oxide in an atmosphere of carbon dioxide. Carbon and hydrogen get oxidized to carbon dioxide and water, while the nitrogen present in the organic compound is converted into free nitrogen. A part of the nitrogen may get oxidized into oxides of nitrogen. When passed over a heated copper gauge, these oxides of nitrogen are reduced into free nitrogen again. The mixture produced, which contains carbon dioxide, water, and nitrogen, is collected over an aqueous solution of potassium hydroxide. This solution absorbs the carbon dioxide gas from the mixture, leaving nitrogen behind. This nitrogen is collected in the upper part of the graduated tube. From the volume of this nitrogen collected, the percentage of nitrogen in the compound is calculated. If the mass of the organic compound is m grams, the volume of the nitrogen collected is V1 ml at room temperature of T1 Kelvin. The atmospheric pressure is P and the aqueous tension at T Kelvin is P dash. Then, the pressure of nitrogen gas at T Kelvin is atmospheric pressure P minus aqueous tension P dash. Let this be equal to P1. Then, the volume of nitrogen at STP is equal to P1 mm multiplied V1 ml multiplied by 273 Kelvin divided by the product of T1 Kelvin and 760 mm. Let's assume that the resultant volume is VML. As we know, 22,400 ml of nitrogen weigh 28 grams at STP. Therefore, VML nitrogen at STP weighs 28 multiplied by VML divided by 22,400 ml. Nitrogen is also estimated by another method known as the Geldahl's method. The method can be divided into two major stages, namely digestion and distillation. During the digestion stage, the nitrogen present in the organic compound is converted into ammonium sulfate. This is achieved by heating the compound in Geldahl flask with concentrated sulfuric acid in the presence of small amount of copper sulfate. Now, the contents of the flask are cooled and transferred into a distillation flask and heated with concentrated sodium hydroxide to liberate ammonia gas. This is the distillation stage. The ammonia produced in this process is absorbed in a known volume of excess of standard solution of sulfuric acid. Therefore, the amount of ammonia produced can be determined by estimating the amount of sulfuric acid consumed in the reaction. It is done by estimating the unreacted sulfuric acid left after the absorption of ammonia by titrating it with standard alkali solution. The difference between the initial amount of acid taken and that left after the reaction gives the amount of acid reacted with ammonia. Let's assume that the mass of the organic compound taken is m grams. The volume of sulfuric acid of molarity m taken in the flask is Vml. The volume of sodium hydroxide of molarity m used for the neutralization of excess acid is V1 ml. As per the stoichiometric equation, V1 ml of sodium hydroxide of molarity m is equal to V1 by 2 ml of sulfuric acid of molarity m. The volume of the unreacted sulfuric acid of molarity m is equal to V minus V1 by 2 ml. V minus V1 by 2 ml of sulfuric acid of molarity m is equal to 2 multiplied by V minus V1 by 2 ml of ammonia solution of molarity m. From the equation, we get that this is equal to twice the volume of the ammonium solution of molarity m. We know that 1000 ml of 1 molar ammonia solution contains 17 grams of ammonia or 14 grams of nitrogen. Therefore, 2 multiplied by V minus V1 by 2 ml of ammonia solution of molarity M contains 14 multiplied by M multiplied by 2 multiplied by V minus V1 by 2 divided by 1000. Therefore, the percentage of nitrogen is equal to 14 into M into twice V minus V1 by 2 divided by 1000 and multiplied by 100 by M. It is important to note that gel-dal method is not applicable when nitrogen is present in the ring, as well as in nitro and azo compounds. This is because the nitrogen of these compounds does not change to ammonia sulfate under these conditions. Halogens are estimated by Carrier's method. In this method, a known mass of organic compound is to be heated with fuming nitric acid in the presence of silver nitrate in a hard glass tube called Carrier's tube. In this process, carbon and hydrogen are oxidized to carbon dioxide and water, while halogen is converted into silver halide. The halogen forms a precipitate of silver halide. This precipitate is filtered, washed, dried, and then weighed. Let the mass of the compound taken is m grams and the mass of the silver halide formed as m1 grams. 1 mole of silver halide contains 1 mole of halide. Therefore, the mass of halogen in m1 of silver halide is determined by dividing the product of the atomic mass of halogen and m1 by the molecular mass of silver halide. Therefore, the percentage of halogen is equal to the atomic mass of halogen multiplied by m1 multiplied by 100 divided by the product of molecular mass of silver halide and M. You have now reached the end of this module. In this module, you learned that the proportions of carbon and hydrogen in an organic compound can be detected by burning the compound in the presence of excess oxygen and cupric oxide. For estimating the proportion of nitrogen, 2 methods are used, the Dumas method and Gel-Dal's method. In Dumas method, a known mass of an organic compound is heated strongly with coarse cupric oxide in an atmosphere of carbon dioxide. In Gel-Dal's method, the organic compound is heated with concentrated sulfuric acid. Gel-Dal method is not applicable when nitrogen is present in the ring and also in nitro and azo compounds. For the estimation of halogen, a known mass of organic compound should be heated with fuming nitric acid in the presence of silver nitrate in a Carrier's tube.